Welcome to The Explainer. Today, we're doing a high-tech forensic teardown of something absolutely wild. We're looking at the flight computer inside the alleged 1980s Alien Reproduction Vehicle. You might know it from the source docs as the ARV or the Fluxliner. Now, the texts we're analyzing don't talk about alien magic. Instead, they describe a brutally elegant machine built entirely with terrestrial 1980s material science. It's an unbelievable look at extreme engineering, so let's just jump right in.
So right off the bat, we run into a massive engineering paradox. The source documents present this crazy challenge. How exactly do you control a craft that is, for all intents and purposes, a contained apocalyptic electromagnetic pulse storm? I mean, this wasn't a normal jet pushing air. The ARV's engine was completely electrical, and the forces inside that hull were just off the charts.
The source claims that to actually warp gravity, using something called the Biefeld-Brown effect, which is basically using insane high voltage to create thrust, the ARV's engine had to pump millions of volts of direct current straight into its floor plates, and it had to do this thousands of times every single second. As you can imagine, this rapid-fire massive discharge creates a continuous electromagnetic pulse, or EMP. That's a totally lethal environment for standard electronics, and, absolutely fatal for the human pilot sitting right on top of it.
To figure out how they got around this, we're going to trace the exact path of a steering command. We'll cover 1. The lethal EMP paradox, 2. The fly-by-light solution, 3. Inside the Faraday vault, 4. Hardwired ASIC processing, 5. The Optic spark plug, and 6. Steering the lightning. Let's go!
Starting off with Part 1, the lethal EMP paradox. Okay. Pay attention to the number 48. According to the text, the floor of this ship is made up of exactly 48 independent barium titanate capacitors. Barium titanate is this heavy, glass-like ceramic that essentially acts as the ultimate electrical sponge. The floor is chopped up into 48 wedge-shaped sections, kind of like pizza slices, that all act together as one giant high-voltage distributor cap. And pumping millions of volts into these 48 slices is what supposedly generates that directional mass reduction field.
But here's where we hit that paradox we talked about. If the pilot tried to use a regular joystick wired up with copper, well, that copper would act exactly like an antenna. The EMP from those floor plates would surge right up the wire, instantly melt the silicon in the flight computer, and, electrocute the pilot. So what's the workaround? Fiber optics. Because fiber optic cables are made of glass and use photons or light to transmit data, there's literally zero metal involved. They are 100% immune to all that electromagnetic chaos.
Which brings us to Part 2, the fly-by-light solution.
So the pilot's joystick inside this ARV was entirely optical. Think of it as an optical potentiometer. When the pilot physically pushes that stick forward, they aren't closing any electrical circuits. Instead, that movement adjusts a tiny physical shutter or polarizing filter hidden right inside the base of the stick. That shutter smoothly changes the intensity of the light passing through it. So a physical hand movement instantly becomes safe, fluctuating pulses of laser light traveling down a glass cable, totally isolated from the lethal electrical storm, raging just inches away.
Now let's look at Part 3, inside the Faraday vault.
All right, enter the Faraday cage. The source explains that the ARV's central flight computer was locked inside this massive, seamless, heavy metal box. We're probably talking copper mesh or mu metal, which is this specialized alloy that just eats magnetic fields. This vault completely blocks out the EMP storm inside the ship. No metal wires whatsoever go in or out. Only those glass fiber optic cables are allowed through. Safe inside this heavily armored vault, the computer can actually survive to read the pilot's commands. Once the light from the pilot's joystick enters this perfectly quiet, safe vault, it strikes a sensor called a photodiode. The documents explain that this photodiode turns the incoming light intensity back into a low-voltage electrical signal. So if the light is super dim, it might output just 1 volt. If it's blindingly bright, maybe 5 volts. Right after that, an analog-to-digital converter, or ADC chip, instantly translates that raw voltage into binary code. The ones and zeros that a computer can actually work with.
Moving on to Part 4, hardwired ASIC processing.
The absolute most important number here is 0. We are talking 0 latency required. If this flight computer lags for even a single millisecond, or if some random software glitch delays the firing sequence to those 48 floor plates, the gravitational field collapses asymmetrically. And the documents are crystal clear on what happens next. The 30-ton ship instantly flips upside down and drives itself into the dirt at Mach 5. So there is zero room for a software crash here. To absolutely guarantee that zero latency, the engineers used ASIC chips, application-specific integrated circuits. This is such a brilliant workaround. It means the insane phase array math needed to distribute the thrust isn't just some program running on an operating system, it is permanently physically etched right into the microscopic wiring of the silicon itself. The math actually is the hardware. It takes the pilot's digital command and flashes it through hardwired algorithmic pathways in a fraction of a nanosecond. No loading, no crashing.
And that brings us to part 5, the optic spark plug.
After crunching the math, that ASIC chip triggers a huge bank of 48 individual high-speed lasers inside the vault. Those lasers then shoot pulses of light back down 48 separate fiber optic cables straight to the engine room. But wait, how does light flip a high-voltage switch? Well, the text points to actual, real-world patents to explain this. Take this 1978 Westinghouse electric patent, for example. It outlines a high-power semiconductor switch, a thyristor, that isn't turned on by a wire, but by a pulse of laser light shining directly onto the silicon. Mind-blowing, right?
And then you pair that with this 1985 Navy patent for an optoelectronic distributor. The documents essentially present this as the literal blueprint for the AIR-RV's rotary spark plug. By firing a rapid sequence of lasers down those fiber optic cables, the central computer can safely trigger massive high-voltage electrical discharges. It instantly unloads millions of volts into specific barium titanate floor plates, all without creating a deadly electrical arc that would just weld a normal metal switch shut.
Finally, part 6, steering the lightning. Let's see how this all comes together.
This whole process is just a masterpiece of totally paranoid, closed-loop engineering. In literally a fraction of a millisecond, here's what happens. The pilot pushes the stick. That physical movement changes the light intensity. The photodiode and ADC flip that light into digital math. The hardwired ASIC chip crunches the math and fires off 48 lasers. Those lasers hit the photosensitive switches and boom, a 1,000,000-volt surge dumps into the floor. It is an insanely fast optical to electrical to optical translation.
And by dynamically shifting that extreme voltage across those 48 plates, the ship actually steers. So, let's say the pilot wants to dart forward. The lasers trigger 5 million volts to the front plates, maybe 1 million to the middle, and absolutely 0 to the rear. By distributing the charge asymmetrically like that, the ship shifts its center of gravity. It basically just seamlessly falls forward into the artificial vacuum, the localized gravity well that it literally just created for itself.
So, to wrap up this forensic teardown, the source paints a picture of just a brutally elegant machine. These archonic engineers in the 1980s managed to achieve perfect isolation from lethal EMP storms by building this optoelectromagnetic loop. They basically took the 1920s electrogravitic physics of the Biefeld-Brown effect and fused it with 1980s material science, things like fiber optics and barium titanate. They built a system that safely used the speed of light to steer an apocalyptic lightning storm.
Which leaves us with a genuinely thrilling and honestly provocative thought to chew on. If these source documents are actually accurate, and defense contractors had already mastered the art of steering millions of volts of lightning using fiber optic light way back in the 1980s, what kind of technology is steering the silent sky today? Thanks so much for joining me on this explainer. I hope it gave you a really clear, structured look into the fascinating engineering described in these texts. Keep questioning and keep learning.